This is James, and I'm just going to go through this rigging system called Flow. So we'll first look at the rig here. It's pretty standard. This is biped character. You can see we've got the hierarchy of the character. We've got the assets in this rig. I can just show the bind joints. So here we've got a skeleton asset, and we've got the model as well. We've got a few extra things, and then under components we've got each section of the rig, so the arms, the legs, the clavicle, things like that. And that's kind of the finished product, and this is going into Unreal, so it's kind of got a single hierarchy for the skeleton. And what this looks like in Flow is this, and the idea of Flow is it's a node-based rigging system. So everything you can see here in the components, each one of these is represented by a node that has inputs and outputs and certain options that you can set. So for example, in here we have the global, which is the global control of the rig, and currently we're looking at the anim version, so there's a tab here and this is a graph for the anim version. So the global node, you can set a few things, the name, the path, if it's an asset that you're loading, or a graph from somewhere else, but at the moment the path is just local to this graph. So looking at a few things, these after we built the global, we want to build the spine. So there's a few different things in here. So the chain that we're going to be building this rig off. So you can see what's going along here is once we've built the global, we're going to bring in the skeleton asset. And moving down here, we can see it's got an asset path, and this is a path to the skeleton file. And the same for the model as well. So this is the name of this is model. We can change that if we want to, like anim model. And we can see a few extra things here. And the asset path is what we're going to be importing, and the method we're going to do is we're going to import this. And a lot of this is just work in progress, so some of this is going to get cleaned up, but we can do things like store pause, store settings, and store spaces on that as well. So moving from there, we've got the spine, and how the spine is going to build is using the chain here, which is just a wildcard search, which is going to be the joints that are in the skeleton. So at the moment that's just a wildcard search for joints in the scene. If we wanted to, we could start to connect some of these things. Oops. So here you can see pressing 2, we can see what's currently connected. So all these nodes, their computes are connected. So essentially when we compute the global, it's going to compute the skeleton, which is going to bring in the skeleton. It's going to compute the model, so it's going to bring in the model, and it's going to run the compute on the spine, and that's going to pass down the rest of these. So if I just expose this, so 1, 2, and 3 to show different things. Here we can see it's just the compute that's going in here, but we can also change things. So here we've got the chain. So if we wanted a custom chain, we can connect that attribute into the chain attribute here as well. So doing things in a more procedural way, so you're not relying on names that exist in the scene. But for now, we're just using hard-coded names. So moving from there, we've got like custom names that we can use. Things like IK and FK we can enable on these guys as well. So we've got IK and FK on here. Stretch is switched off for the moment. And then we've also got space switches. So for the IK lower controls, so that's going to be the hips, and the upper we've got the chest. We've got these different space switches set up. And we're going to show you what that does in a minute, but this just exposes what spaces you want for those controls. Quickly going over these again, we've got the neck, same sort of setup, IKFK, the chain it's going to build on, things like that, what spaces we want. And then we've got like things like the clavicle, the arm. It's kind of similar setup here. We've got different options, so the IK offset is going to automatically place the IK pole vector, and we can say how far away we want that. IK and FK, things like that. So the arm and the leg are both using the same type of node, which is just this generic limb node. And this gives you the generic behavior for any type of limb, and then if you want to, you can kind of subclass that and create kind of custom limbs. So these arms and legs, the main thing there is we have a thing called the posture and the structure. So at the moment it's just set to plantigrade because the biped is a plantigrade character. So that's going to define a few things of how this limb is set up. And then again we've got the fingers below that. And we can set the same attributes on those. Down here as well we have the display attributes. So these are the attributes of the node, and these are attributes of how the node is displayed in this graph. So we've got the label size, different things like that, and this is going to be expanded a bit more, so you can change the colour, the shape of these, and all sorts of stuff. So that's kind of like the overall graph, and again, like you can right-click, create different nodes from Maya or third-party applications. You can go ahead and create these, and then rename them, and do all sorts of things. So how that's working in the rest of the rig. So I'll just select one of these, for example. So the left arm, we can see the IK space. It's got all these different spaces, so they can follow the FK, it can follow the clavicle, the upper or lower parts of the spine, center of gravity, or the global or the world. And what this is going to do is, that's the left arm. If we go back to the character and have a look at the left arm component group, we have an input and output group, so any spaces going into and out of this component. So we're keeping, even though this is very object orientated, so each node is a separate kind of container object, and you've only got definite inputs and outputs. We're kind of reflecting that in Maya, so each one of these is kind of a group, it's a kind of a component, and any way that it interacts with anything else goes through these input and output groups. So what we're going to see is, for each one of those spaces, it has created a space group. And what we're going to do for these space groups is they're going to be matrix constrained to whatever other part of the rig. So if we want the left arm to follow the left FK, it's going to create a left arm FK space in, and this node is going to be driving that IK control. So that's kind of how the space switches are set up. And the same again, like any outputs we want to put out. So we've got there's an auto pole vector null. That's just a matrix where the auto pole vector is going to be placing the pole vector. We've got the IK controls world end, where it's bending, pivots, things like that. So we can create any type of spaces that we want to export as well. And how this is working when we export this is, let's go back here. When we export this graph, so as you can see, the graph is an anim. We're currently looking at the anim rig. So this is a node itself as well. So the anim rig is a node. This is the graph inside that node, and then again inside some of these you can expand them, and they've got their own kind of subgraphs as well. So at the moment we're looking at the anim graph, and if I just show what that looks on disk, is we've just got a flow graph, a JSON file with all the data in there, and that represents any data that's native to Flow, not to do with Maya or any other applications. This is all data just to do with this graph, this Flow application, and that can be boiled down to JSON data. And then anything else that's application data, so certain things that we don't want to store in a big massive graph file, we're going to store under the separate nodes themselves. And again, following that same object oriented thing, that we've got nodes in the graph here for each of the parts, we've got groups for each of the components here. It's the same for where we're actually going to store the data. So we can go through here and, for example, go to the left arm again, or go right arm, doesn't really matter. We've got different things, so the stages that this is going to do. So if I actually go to the left leg actually, we've got different types of data. So here we've got the data needed to build the limb, and what this is going to be is any objects that we need. So it's got controlled curve shapes in there. It's got matrix information of certain things we want to place, and we'll show that in Maya in a second. It's got the connect, so when we connect this limb, It's got all the space switch information there, what's connected to what, and the methods that it's been connected by. And then we've got the setup as well. So first we do the setup, and setup is anything we need before we build a rig. So for example, a leg, which we'll show in a second, has certain locators for the foot roll, and those locators, the matrix of those locators gets exported here. So for example here, we have so the node is the left leg inner pivot matrix. It's got the package that's come from, and it's just got the value, and that's going to be the matrix of that locator. So we can edit that in Maya or another application. We can export that data as a matrix and then re-import it and rebuild the same rig. So if we just go back here, let's go to this leg. So we'll show this off. And this is going to be under setup. So we have a left leg setup. I'll just isolate that. So what we have here is just 4 locators that we need in order to do the foot roll. And they have been moved and fitted to the model. And the reason we're using these locators is because the skeleton itself only has a very simple foot roll. It's just the pivots of the joints. So we don't really want to over complicate that skeleton file. We don't want to add a million different nodes for every bit of data that we want to store, because that can quite easily get out of control and it becomes very tied to Maya. So just by having the skeleton just for the joints, and then any extra nodes that we want is this setup here. So it's going to use those nodes to basically position the foot roll. So that's where we're getting this heel control from. It's using the matrix of that instead of the skeleton. So first it's going to use that setup, then it's going to build it. The way that it's building it is it's using the plantigrade, like we mentioned before. So go back to the leg. Scroll down here, it's set to plantigrade. So it's going to do plantigrade foot, and like we saw in here in the build data, it's got all the information of all the control curves, all the control points, all the colours we've used, different control shapes, and it's got the keys that we've used inside the code for these different parts. So all that's exported. So that's all we need to build this rig. What we have here now is just the exact same graph setup, but this has been, a few things have been changed to the model and the skeleton. So a different skeleton has been created to fit this character, which has slightly different proportions, but using the same exact graph and same exact data, we can now create the exact same rig on a completely different character. So we've got the same space switches, same connections for everything. So from one biped to the other, the only thing you'd probably need to change is the skeleton if the proportions are different, and then obviously like the skin weights. I think this one needs a few improvements, but we can quite quickly, take one rig, transfer it to another, especially for bipeds. And then one extra way that we can show this as well is we can use the exact same graph again for a quadruped. So this is using the exact same setup, all the exact same data, all the exact same space switches. The only addition here is we've got a tail node added, so we can add more nodes on there. But again, it's got the exact same stuff. The only difference there would be any position locators that we want for the foot roll. It's different. And again, this character is digigrade. So what we would do is in the graph, as we saw on the legs, it's got or for the biped it's set to plantigrade. So having the graph of this set to digigrade means that we're now going to create this digigrade leg, which acts in the way that we'd expect for digigrade. And then we've also got yield grade for cows and horses. But again, all set up the same way. The components are exactly the same. If we look at the leg, we have the input and outputs. And because all these space switches are exported as data, we can instantly, transfer that between characters, even if it's a biped to a quadruped. The only difference there, which we would need to fix, is obviously the control curves. So these are fitted to the model. But again, we can export that data, and then the next cat or dog character, or quadruped that's quite similar, you can transfer those things across as well. Okay, so that's just a quick overview of what's going on. It's very still very work in progress, but the idea is mainly this is very procedural, and it's not tied to Maya in any way, apart from what it's actually doing to build the rig. So some of these things can be transferred to different 3D applications as well, and all this data is 100% exportable, so it's a lot easier to transfer between different rigs and procedurally build rigs quicker as well. Cheers, thanks, bye.